Good day, everyone. Today we'll be looking at applications of differentiation for maths level 4, and our application will be focusing more on the cubic graph. So that is our cubic graph. We are going to calculate coordinate of the turning point, then we determine the equation of the tangent at x equal to -2, then we calculate the coordinate of the point of inflection. Then we study the nature of the turning point, we calculate the x and the y intercept of the function, then we sketch the graph. So that is our lesson for today. So I want to start with A. So the A part says we need the coordinate of the turning point. So definition of turning point says our first derivative must be equal to 0. So that means I'll differentiate that function once. So if I differentiate it once, what does that mean? If you differentiate that, you will get 6x squared minus 14x plus 4 equal to 0, which of course it's a quadratic equation, and the degree, which is the highest power of x, is indicating to me that I must get two turning points. So since it's a quadratic, the best option which I would advise you to use to solve it is the quadratic formula, which is no longer given on the mathematics level 4 formula sheet. So that is why I'm writing it here, hoping that everyone is familiar with that formula. So with this formula, I'm substituting into it. So my b is -14. So I'll get negative into -14, then plus or negative the square root of -14 squared. Sorry, this is -14 squared minus 4. My a is 6, then my c is 4, all this on 2a. So that is what I have now to use my calculator to calculate so that I can get the x values. So if I do my calculation, it means I'm taking 14, then plus the square root, then -14 squared, this is 196, then this is 24 times 4, so minus in bracket 24 times 4, bracket close, then I divide by 12, so that is giving me a 2, so that gives me a 2. I only use the positive sign. Then the other one, I'm going to just replace the positive by a negative, and that is giving me 1/3, which you can also call it 0.33, whichever. So those are the x ordinate of the point of intersection. These are not the point of intersection. Sorry, x ordinate of the turning point. So you see we need the coordinate, which means for every x value, I must get the corresponding y value. So how do I get the y values? So I will continue here. I will say if x is equal to 2 for the first one, then my corresponding y value I must put into that equation, the original equation, which is 2 into 2 cubed minus 7 into 2 squared plus 4 into 2 plus 4. So if I can use my calculator for that, I'll get my 2 cubed, then minus 7 into 2 squared, then plus 8 plus 4. So when I substitute x as 2, I'm seeing 0. So this shows to me that I've got one of the turning point as 2, 0. Then I will do the same thing with the other point. So I'll say if x is equal to 1/3, I'll also substitute 2 into 1/3 cubed minus 7 into 1/3 squared plus 4 into 1/3 plus 4. I can call it 1/3, 0.33. So here. 1 over 3 cubed square is 1 over 9, so I get my minus 7 over 9. Then this will be 4 over 3 plus 4 over 3, then plus 4. So I guess that is what I get. So it gives me 4,63 if I'm putting it in decimals. It gives me 4,63 if I put 2 decimals. So the other turning point is 1 over 3 and 4,63. So 1 over 3, I think I'll prefer decimals for all of them. So I get 0,33 as we indicated down there. So it's 0,33 corresponding to 4,63. So those are my coordinate of the turning point, guys. So when they say calculate the coordinate of the turning point, so you know that you must get the x and the corresponding y value. So here we got our x values by equating the first derivative to 0, we solve our quadratic, then we substitute each x value into the original equation to get the corresponding y value. So these are my turning points. So I think the A part we are done. So we can now go to the B part. The B part, we are now calculating the equation of a tangent to the curve. So generally what we call a tangent is a straight line that touches a curve. Let's just say our exponential graph is like this. If I can get a straight line touching the curve there, then the name of that straight line becomes a tangent. So its equation should be y equal to mx plus c. So each time I'm told to determine the equation of the tangent at any point, all I need to do is to know that I'm looking for y equal to mx plus c. So that is what I'm doing. So to get my m, I need the first derivative. Luckily, the first derivative, we got it already. So my first derivative was 6x squared minus 14x plus 4. So if I go now at x equal to minus 2, since we're looking for the tangent at x equal to minus 2, all I need to do is substitute, replace x there by minus 2, so that will automatically become my m, which is 6 into minus 2 squared minus 14 into minus 2 plus 4. So 6 squared, sorry, negative 2 squared is 4. 4 times 2 is 24. So I get 24 plus negative 14 times negative 2 is 28. Then plus 4. So that gives me my gradient as 56. So now that I see my m, I immediately bring it there. So my equation becomes y equal to 56x plus c. But you can see we still need c. And to get c, all I need is to substitute the values of x and y. And for now, we know x as negative 2, but we don't know y. Each time you need y, just like we were looking for y and the coordinate of the turning point, we must go back to the original equation. So I was saying again that at x equal to negative 2, this implies that my y will be equal to, I go back to the original equation, I say 2 into negative 2 cubed minus, it's minus 7 into negative 2 squared, then plus 4 into negative 2, then plus 4. So negative 2 cubed is 8, negative 8, sorry, times 2 is negative 16, then negative 2 squared is 4 times negative 7, it's negative 28, then negative 2 times 4 gives me negative 8, then plus 4. So I've calculated to see that my y will be equal to negative 48. So I now know my x as negative 2, my y as negative 48. If I substitute into this equation, I should be able to get my value for c. So therefore, I'm taking y as negative 48 equal to 56 into x, which is negative 2 plus c. So if you multiply that, it should give you a positive number, 56 times 2 gives me 112. So it's negative 112 this side, if it crosses that side, it will become positive 112. So I will subtract 48 from it, and that gives me my C, my C as 64. So therefore, the equation of the tangent to the curve at the point x equal to -2 is a simple y equal to m. My m, what was our m again? Our m was 56, x then plus c, which is 64. So guys, that's how easy it is to get the equation of the tangent to the curve. So I guess we are done with the A part, with the B part. We can then go to the C part. So the C part says calculate the coordinate of the point of inflection. So if we call point of inflection POI, we'll say at point of inflection, the second derivative is supposed to be equal to 0. So we already got our first derivative when we're calculating m, the gradient. So to get second derivative, we just go to first derivative and differentiate again. So this means if I differentiate there, I'll get 12x minus 14 is equal to 0. So if I can solve this equation, I'll get the x value. So I'm solving this equation, my x value, I'll carry 14 that side, I'll count 14 and divide by 12, so it's 14 over 12, which simplifies to 7 over 6. So again, this is just the x value. So to get the y value, each time you need y, you must take your x value and substitute into the original equation, just like we were doing it up there. So I'll just be replacing those numbers by 7 over 6. So I'll get 2 into 7 over 6 cubed minus 7 into 7 over 6 squared, then plus 4 into 7 over 6, then plus 4. So 7 over 6, let me see, maybe I would prefer to substitute decimals. 7 divided by 6 is the same thing as 1,667. So I prefer to substitute decimals. So I will say 2 into 1.667 cubed. So I've substituted the first part, then minus 7 into 1.667 squared, that's the second part, then plus 4 into 1.667, then plus 4. So I guess that is it. That gives me y as, this means that y is 0,48. Each time we need the y value, we must substitute the x value back into the original function, which I've done now there, and I'm seeing my y. So therefore, when I call my point of inflection corresponds to the x value, which is 1,667, going with 0,481. It's 481 if I use 3 decimal places. So that is how simple it is to do the C part. Then we can go to the D part. The D part says we need to study the nature of the turning point. Remember, we've got 2 turning points. Our turning point were 2, 0 and 0,33 and 4,6 those were our turning points. So we need the nature. So nature means we don't know which one is maximum turning point and which one is minimum turning point. So if I can bring the turning point closer, there were 2 and 0. The other one was 0,33, matching 4,63. Those were our turning points. So if I need the nature of the turning point, I use the second derivative. So we already calculated the second derivative when we were doing point of inflection, and our second derivative gave us 12x minus 14. So if I need to know between these 2 turning points, which one corresponds to a maximum and which one corresponds to a minimum, all I need is to substitute the x alternate into the equation of the turning point, into the second derivative. So if I substitute the x alternate of this first turning point, that will give me 12 into 2 minus 14. 12 times 2 is 24. 24 minus 14, that gives me a 10. So once the x ordinate of our turning point into the second derivative returns a positive number, then that turning point is a minimum turning point. So therefore, we'll say 20 is a minimum turning point. So most students always get confused with this. They always think that positive goes with maximum, but that's not the way it is. Once you can substitute the x ordinate of your turning point into the second derivative, as we call there, and you get a positive number, that is the minimum turning point. So we'll do the same thing for this one. The other turning point was substituting the second, the x ordinate, which was 1/3. Maybe I'll just put 1/3. 1/3 was the same thing as 0.33. I'll substitute it into the second derivative, that is 12 into 1.33 minus 14. So if we do that, 12 divided by 3 is 4. 4 minus 14 gives us negative 10. And this is one other thing that also shows to you that your calculations are making sense, because when you substitute both x ordinate, one will always give you a positive number, the other one gives you a negative number of the same magnitude. But now that the second derivative at this turning point returns a negative number, therefore that turning point 0.33 corresponding to 4.63 is a maximum turning point. So that is how easy it is to know the nature of turning points, guys. So gradually we are getting closer to the end. The E part of our problem said we need the x and the y intercept of the graph, because after this we need now to sketch the graph. So let's start with the y-intercept. I want to bring our graph closer again. Our graph is y equal to 2x cubed minus 7x squared plus 4x plus 4. So that is the graph that we've been dealing with. So we need the x-intercept and the y-intercept. Those are the points where that graph touches the x-axis and the y-axis. So I want to start with the easy one, y-intercept. So y-intercept, once you are looking for y-intercept, you go through that equation and you say if x is 0, what is y? So if x is 0, it means I go through the whole equation and place every x by 0. If I put zeros there, you see that y is equal to 4. So that shows to you that this graph must touch the y-axis at 4. Now, the x-intercept is the challenging one. So for x-intercept, we do the same thing. We'll say if y is 0, it therefore means the equation 2x cubed minus 7x squared plus 4x plus 4 must be equated to 0. So this is the equation we have to solve. We have to solve 2x cubed minus 7x squared plus 4x plus 4 equal to 0. Under normal circumstances, we expect 3 x-intercept, except maybe some are equal or others are complex, but they should always be 3. So the only thing is that if some are equal, it will touch the x-axis only 2 times. If all the 3 are different and real numbers, the graph must touch the x-axis 3 times. If 2 of them are complex, the graph will only touch once. If all the 3 are complex numbers, the graph will not touch the x-axis and so on. So to solve this, there is no other way out apart from using the factor theorem. So the factor theorem, we have to start by using the trial and error method to check what number can we substitute there to get the same. So we need to try numbers, and since we call it a trial and error method, it means you try numbers that you can just put here, and to guide you not to waste all your energy trying all the numbers on earth, you always target a constant term. The numbers you have to try here should be numbers that are factors of 4, both positive and negative. So if I'm checking factors of 4, there is plus and negative 4, plus and negative 2, plus and negative 1. By the time you substitute those 6 numbers, you will see that one of them must make this 0. For example, if I try 1, I'll see that this first term will be 2. 2 minus 7, then 7 plus 4 plus 4, so that's 7 plus 8. I'm seeing positive 3, so it means 1 is not working. If I try negative 1 cube, that makes this negative 2, so I get negative 2. Then if you put negative 1 square is 1, so I get minus 7, minus 4 plus 4. So it gives me negative 9, it means these two are not working. Then by the time I try the remaining 4, I must win something. So if I put 2 there, 2 cubed is 8, 8 times 2 is 16, then 2 squared is 4, 4 times 7 is 28, so that is minus 28, then 2 times 4 is 8, so plus 8 plus 4, I see 0. So it means I was saying f of 2 is equal to 2 into 2 cubed minus 7 into 2 squared plus 4 into 2 plus 4 is equal to 0. So that therefore tells me that x equal to 2 is a root. You can call it a root or x intercept of f of x. So if that is a root, then it means amongst the 3 x intercept, so the 3 x intercept, we've succeeded to get 1. So we are left with 2. So if I'm left with 2, there are many methods to use. One of the methods I prefer explaining to my students is the synthetic method to get the remaining 2. So how do I use it? I put my division sign, then the first root that I got through trial and error to get me 0, I put outside, then up here, I must put 4 numbers. Those 4 numbers are the coefficient of x cubed, x squared, x, and the constant. So I get 2 minus 7, 4, and 4. And I always insist that these numbers must be 4 all the times. Even if my original function does not have 4 numbers. For example, if our original function there was 2x cubed plus 4x plus 4, you see I have only 3 terms, but I must get 4 numbers. So the first one is from x cubed. The second one is from x squared. You see there is no x squared there. So if I was using that, I'll get a 0, then followed by x, followed by 4. So you must know that in here, all the times, you must get 4 numbers when you are doing the synthetic method. So from there, I'm going now to do addition. With addition, I always start with a 2 there. So if I get a 2 there, I'll get 2 plus 0 is a 2. 2 times 2 is a 4. I'll put under the next person. Negative 7 plus 4 is like 4 minus 7, which is negative 3. 2 times negative 3 is a negative 6. 4 plus negative 6 is a negative 2. 2 times negative 2 is a negative 4. And 4 plus negative 4 is a 0. So that's the way it is. So here, you see clearly that here, this must end with a 0 or you start with a 0. Once it ends like that, then you are confident that you are on the right track. So what you are seeing here is a quadratic equation that will help you get the other root or the other x intercept. So I'll just take my 2x squared minus 3x minus 2 equal to 0 and solve for x. So with these things, I'm looking for the x intercept. I can just equate it to 0. I'm not factorizing completely. So I equate to 0 and solve. So I can substitute this into the quadratic formula where I need negative b plus negative the square root of b squared. B is negative 3 minus 4. My a is 2. My c is negative 2 divided by 2a. So I can do that on my calculator. So I'll get negative 3 is 3. Then I'll go for the positive sign first. Then I'll go to the square root. Negative 3 squared is 9. So I get 9. Negative 8 times negative 2. Negative 8 times negative 2 is plus 16. That's what I see there. Then I'll divide by 4. So if I divide by 4, I see that one of my x values is 2. And what is the other one? I just need to replace the positive values there by negative. Once I do that, I get negative a half. So therefore, I can say those my x looking for x-intercept. I got the first one through trial and error. It was x equal to 2. The second one is another x equal to 2. So x equal to 2 is a double root. Then we get x equal to negative a half. So you can see it's indicating to you that your graph is supposed to touch the x-axis 3 times. But one thing you must see is that 2 of the times 2 of the x-intercepts are the same. So when these 2 are the same, it is reminding you that the point x equal to 2 is also a turning point. And if we can go back to our turning point, you see that 20 is a turning point. So it will be now shown to us that instead of this cubic graph to touch the x-axis 3 times, we only touch 2 times because 2 of this point are the same. So we can now go to the last part, which requires us to sketch our graph. So if I'm sketching my graph, I need to study all the points I've been dealing with in this graph. So the points that are important to me are the turning point, which I know them here, then the x, the y-intercept is 4, my 3 x-intercept. So those are the points that are important to me. So on the x-axis, I know I will need 2, and I think that is the biggest point on the x-axis because the turning point others are there. So I see that my x-axis needs one positive point or there is one negative point. Then on the y-axis, my biggest point I'm seeing a 4 or there's also a 4,6. So that can give me an idea to sketch my graph. So on my graph, I need more of the positive x and y axis. So I'll try to open that. So this can be my xy plane. So I've got my 1 here and my 2 there. Let me put it there. Maybe I increase it a little bit, 1 and 2, because on the x-axis I don't need too many points. Then on the left, I need a negative 1 there, because it's either on the negative value of the x is negative a half. So it's like I'm down with the x-axis. On the y, because the turning point has 4,6 and the intercept is 4, it means I will try to get my point maybe up to 5. So I'm just doing this for the sake of students that are not given a graph page, but I know for level 4 students, you are so blessed. The examiner always designed this graph page for you. So for the y values, I'm not seeing any negative. I don't think I see any negative because the turning points they are all positive, y-intercept. So I really don't see any negative. So we don't need anything that much below the x-axis. So it's now time to plot the important point. The important point for me are the intercept first. X-intercept, the graph must touch the x-axis at 2, which is a double point, which means 2 will be the turning point. Then you also touch at negative a half. So if this is negative 1, negative a half is somewhere in the middle. Then the y-axis, my y-intercept is 4. My graph will touch at 4. So I've plotted the points that are easy to plot. Now the next thing is the turning point. We saw that 2 is an intercept, but it's a double point, so it's also a turning point. And from when we studied the nature of the turning point, 2, 0 was the minimum turning point. So we are expecting that at this point, our graph should have this shape. That should be the shape of our graph. It must be turning here. Then the difficult point to plot is the maximum, which is 0,3 and 4,6. So if this is 1, 0,5 can be somewhere there. Maybe this will come out 4,3. So that can be like 0,3. Then 4,5 can be there, and 4,6 is there. So when we study the nature of this turning point, we all agree that that is the maximum turning point. So I've put all my turning points. So knowing that this is a maximum turning point means I expect my graph to pass through that point like this. So if you have a good look at it, you see that it will then link up with this one continues. Then this graph must also go down and cut the x-axis at negative a half. So that is it. So guys, this is the shape of our graph of f of x equal to 2x cubed. This is 2x cubed minus 7x squared plus 4x plus 4. So generally, we always say when the coefficient of x cubed is positive, your graph starts down and ends up. If it is negative, you're supposed to start up and end up. So, ladies and gentlemen, that is all about our cubic graph. Thank you very much.